Hi everyone, welcome to graphing cosecant and secant, example 1. We talked about where the asymptotes will be for cosecant, which is the reciprocal of sine, and then we talked about where the asymptotes would be for the secant, which is a reciprocal of cosine. So we're going to use those points to make the asymptotes. Then we're going to find where the lows and highs are. We're going to find the period, and then we're going to use those graphs of sine and cosine, and then sketch in cosecant and secant. So the first thing we need to do is y equals 3 sine, and we're going to write this as 1/2 x, as many of you have seen or have discovered in your graphing in graphing sine and cosine functions. So what I'm going to do now is identify that the a value, the amplitude, is 3, and then I'm going to find the period, which is 2 pi divided by 1/2, and that is 4 pi. So what I'm looking at here is I'll graph the sine curve in blue, and then I'll graph the cosecant curve in red. I'm going to graph the sine curve that has an amplitude of 3 and a period of 4 pi. So its halfway point is going to be 2 pi, pi, and the other interval with 3 pi. The sine curve does not undergo any horizontal phase shift or vertical shift, so it's going to be anchored here at 0, 0, go up to 3, down to -3. So there's the sine curve of 3 sine 1/2 x. Now, in red, I'm going to graph the cosecant. Remember that we have asymptotes here where the sine equals 0. And then we've got, just make that, there we go, more like an asymptote. Okay, now I'm going to take the high point of sine and make that the low point of the secant curve. Cosecant curve, excuse me, I keep doing that. And then I'm going to take the low point of sine and make that the high point of the cosecant curve. And so that, in red, is the graph of the 3 cosecant x over 2. Now, if you wanted to graph 2 secant 3x, let's go back to blue. I'm going to take this, understanding it's a reciprocal of 2 cosine 3x. Well, the a value is going to be 2, that's my amplitude. The b value is 3, and so I have to find the period by taking 2 pi and dividing it by the b value. So the period is going to be 2 pi over 3. So that means that from 0 to 2 pi over 3, I can expect to see one full curve of the secant. For now, though, with an amplitude of 2, I'm going to graph the cosine curve. All right, so I have to do a little bit of math here to figure out halfway between 0 and 2 pi over 3. Let's see, that would be, so I could take 2 pi over 3 and divide it by 2, and I would get, let's see, 2 pi over 3, and that's the same as multiplying by 1/2, so I would get 2 pi over 6, or just plain old pi over 3. Well, of course, that makes sense. Halfway between 0 and 2 is 1 pi over 3. Okay, now, halfway between 0 and pi over 3, that's going to be pi over 6. I know that because if pi over 3 is 60 degrees, half of that is 30. And now, halfway between 60 and 120, that's going to be 90. That's going to be 3 pi over 2, or in other words, 4 pi over, 6 pi over 4, but 3 pi over 2 because halfway between 60 and 120 is 90. Whoops, let me change that. Halfway between 60 and 120 is 90. There we go. Okay, so I'm going to graph the cosine curve, sketch the cosine curve here in blue. Down here, through 0, and back up. And so the cosine curve looks like that. Now, in red, I'll draw my asymptotes, where the reciprocal of 0 is undefined. Then I'll graph my secant curve using the high and low points of my cosine curve. Okay, and there you have 2 secant 3x.